So in this podcast, we're going to quickly go through how to make box plots, advanced kind of box plots using ggplot2. So this one should be pretty quick. So I'm not going to discuss much of the details of what box plots are or what they mean. I've sort of covered that already in the previous podcasts for basic box plots in R using base and also the advanced one. So we're just going to kind of quickly rattle through this. So I'm working here in my project folder here for this this entire project with the files. At the minute we've got L10 Boxplots Advanced. We're in there and we're working on this file here, the 10b lecture 10b Boxplots ggplot2.rmd. So that knits to this. So you can follow that along over here if you want. So that knits to this document here. So we're going to create these figures and just have a quick look at how to generate this type of imagery in ggplot. So as before, you're going to remove everything in the environment. You can see here I've restarted my R session, which I've explained is better practice. We're going to load the ggplot2 library here. So I'm just going to run that one there like that. We're going to then again look at this iris data set. We're very familiar with it now at this stage, but just to remind us, structure of iris, we've got these three species of plant, these three species of iris, and we've got various measures on the characteristics of the flower: sepal length, sepal width, petal width, and petal length. So you can see that basically here, down over here, it's going to look something like this. We're going to focus on looking at petal length as a function of the three different species. So we've got Setosa here, the smallest, versicolor in the middle, and Virginica slightly larger. Again, so we can create a very quick basic ggplot here with this command. We're going to create a ggplot. We're going to call it the created object P1, the plot. Create a ggplot again, specify the data set from where it's going to come, so that's iris, and then we just specify the aesthetic mapping. So on the x-axis we want species. Species is a categorical variable. R will take care of that once it sees that internally, the ggplot, and then the y-axis we want petal length. So our response variable is petal length, and x on the x-axis is species. That's our basic plot. We can take a look at what that does. That creates a basic plot down over here. You can see we've got the species, Setosa, versicolor, Virginica. We've got petal length in the appropriate range based on the data that it can see. There's nothing on the plot, and that's because we need to add a geome or add a geometry on top. The geome we're going to add is geome boxplot. It's that easy. And then after we add that, again with the plus symbol, so we create our ggplot basic plot here like that, and on top of that we add with the plus symbol the geome boxplot. And then after we've done that, because we've created it into an object P1 that won't print it to screen, it'll keep it silent until we call specifically print P1. So we can run those two lines like that, and we get a very basic box plot but it's very, very similar, almost pretty should be identical to the one we get in base R. Again, it's got all the characteristics with the median, the interquartile range, the whiskers extending to 1.5 times the interquartile range, and then unless it hits the max or min, and after which it stops and produces these outliers here. We can then do a lot of embellishments as always with ggplot. We can, if you want, you can flip the coordinates to the horizontal. So we're going to create P2, which is based on P1. It's based on this P1 plot over here. All we're going to do is add a coord flip on it. So that coord flip is useful for any project you're going to do. It's going to flip the coordinates, basically rotate them 90 degrees. So you can look at that output there. And we got exactly the same. So now we've got petal length on the x-axis, extending for three different species: Setosa, versicolor, Virginica, just as before, just rotated. Personal preference. I mean, I think my advice would be always plot your response variable on the y-axis. It makes far more sense. But there might be occasions when it makes sense to do this for visual reasons. Maybe you're making a really fancy plot with some extra information on here too, and you just need to show quickly what these distributions are in the horizontal. You can change outlier color and shape very easily. So here again, we're going to create, actually before we do that, we're going to do the notch plot. So remember, you can do these notches. We covered these before. These provide a confidence interval around the median. It's defined as, you can look at this, it's defined as 1.8 times. So here's a bit of, this is something new actually for us. You can write maths very easily in R Markdown. Maths gets written in the style of what's called LaTeX format, but to put it between two $signs in the text part of a Markdown file. This /PM, this backslash means this is some sort of special symbol or character. Usually that's the PM is the plus minus symbol. Times, plus minus 1.58 times, and then text, I want IQR to be written in text, and normally it'll write letters as italics, assuming it to be like a parameter value, divided by the square root of, and that's another function symbol, n. So you see there it's hovering over here for me. So we've got the plus or minus, the slash pm has come out as plus or minus symbol. 1.58 is right beside it. The star means multiply. IQR is rendered as plain text, not italic text, because of the text brackets, those curly brackets you'll see here define, these formatting ones. You typically take curly brackets divided by the square root of n. So you can Google away to your heart's content for that, but that's how that does. And you see when you hover over, you get this nice rendered version of that maths, and then the document you get nice rendered maths too. So yet another major bonus for Markdown. But moving on, so that's what the notch, I suppose, gives us an idea of how confident we are in where that median is. So you'll see in these box plots back over here, these horizontal ones, we have a median there. We're not sure how confident we are in the location of that. How confident we are in that depends on both the spread of the data, the IQR, the interquartile range, and also how many data points we have. The more data points we have, the more certain. The less data points, the less certain. And that's exactly what this mathematical formula tries to capture. I won't go into the maths exactly behind that, but you can just take it on face value. You can certainly read up on that more if you want in a general, any stats book will tell you that. I'm sure Wikipedia will too. So we can add those notches really easily if you want. We're going to create P3 as an object, again, just as before, a ggplot. This time when we add the geom boxplot, we're going to add just the option as notch equals true. That's it. And we're going to print that as well, so we can run all that there. Now we get these notch box plots, so you can see the notches give you an indication of how confident we are in those medians. Again, I'm not gone on these notch plots personally. I don't particularly feel it adds a huge amount of information. I'd sooner in the figure legend just be told what the sample size is for each of the 3 box plots there, and I'd sort of make my own judgment call on that. But if you want to add those notches, you can. It's very easy. We can jump on then and we can do further embellishments, of course. We can change the characteristics of the outlier. There's loads of options in geom boxplot. Type question mark geom boxplot, you'll see them all. Actually, even hover over it there, you'll see a full spread of them there, and there's many more probably in there too with the you see with the ... buried in there after position equals dodge. So that will let us make additional embellishments and changes. So that then, here we're going to specify the outlier color to be red, the outlier color shape to be 8. I'm not quite sure off the top of my head what that is, and outlier size 4, so that's going to be bigger than default. Run that little chunk of code there, and we find what we've got now is, so the 8 outlier shape 8 is the star, the sort of asterisk star, and now we've got, basically just highlight the outliers in red if you want in a bigger point size. Again, it's up to you, your choice on what you want to do. And then I think, for me, I think, trying to get this into something of more in line with the publication standard, we want to again make some changes to the theme, make some changes to the font size, etc. So what I've got here is another box plot. I've called it Q, just for difference, just break away from these P4s, which are in this sort of basic inbuilt ggplot style with the grey background and the white grid. Called it Q. So Q is a ggplot, again with this exactly the same mapping of the data and the aesthetic mapping, X species on the X, petal length on the Y. Onto that, we're going to add a geom boxplot, and we're going to fill that by species. So I'm going to this is a new aesthetic, so I'm going to add an aesthetic to the boxplots. We're going to add an aesthetic to tell it to basically fill the boxplot with a color based on the species. Is what I've told it to do. So it's going to pick a different color for each of the 3 species. I've told it to provide an outlier color to be NA, so that's basically actually not going to plot an outlier at all. So it's not, the box plot now is not going to put any outliers, because you'll see what I'm going to do now in a moment. So we're going to tell it not to put any outliers on. We're then going to add a geom point, so I'm going to add a point cloud of the raw data, so I'm going to put the raw data on top of it. Again, tell it the mapping for those points, and tell it to fill by species. So I'm going to fill the color again by species here. This might actually be overkill, to be honest. We might not even need that. It should inherit that from up here, but we haven't told it what the group is. So we do need to tell it though that the geom point, the group is species and the fill is species. So we want to group them by species, so we plot them differently, and we want to fill by species too. I'm also going to jitter them. So if you recall the previous box plot podcast I did, we don't want all the points in a line because you can't see them, and we want to jitter them sideways, and that's very easy in ggplot. The geom point takes a position option. That takes there's various, if you look at the help file for geom point, you'll see what different function methods you can use to locate and position the points. There's one of them is position jitter. It's just like the basic jitter function we used previously. So that's going to add a bit of jitter with a specified width. I just found out what width to use by trial and error, basically by trying a few different plots till I got a width that was doing kind of what I wanted, not too far, not too narrow. Then these options here, actually, I'm going to put a little carriage return there. These options are not to do with the position. These are because we've closed that bracket there. You see that there, and the comma here. Now we're going to specify for the geom point. Shape is 21. So I'm going to pick shape 21, which I think is a little round, it's a sort of small filled. No, it's not actually. It's a point with with color in two different colors, color in the middle, color on the outside. And we're going to set stroke size to 1.1. So stroke equals 1 is the default point size. Stroke 1.1 is a little bit larger. It's 10%, 1.1 times larger. So that's the geom points. So we've got a ggplot with the box plot and the points added on top here. We did a bit of jitter. Now, to specify the colors manually, so this will fill these options here, fill species, fill equal species for the aesthetic mapping, and fill equal species here for the points. We'll color those boxes and points using a default palette, whatever the basic palette is that ggplot uses. I'm going to override that here. I'm going to override it with a new scale. I'm going to manually specify the scale for fill. So scale fill manual will specify manually. I'm going to it will let me write in what colors I want to use for my palette, and it'll pick from those. So scale fill manual, there's other ones in there, there's discrete scales, continuous scales that you can use. Lots of palettes exist already, and we'll probably use them later on in this module. Some of them are particularly useful for getting around colorblind and printing to black and white issues. But scale fill manual specifies the scale to use for the fill option here, and we're going to specify it manually. I'm going to specify that manually with values, 3 values for my 3 groups, C, so a concatenate vector of my values I want to use are pink, yellow, and light blue. And what I want to do is have those be mapped. Those will be mapped onto then the different species codes. So species codes will be Setosa, versicolor virginica, codes 1, 2, and 3. So that should be pink, yellow, and light blue. So that way now the fill for the species matches the fill for the box plots here. We're going to add on to that a guide. So the guide is the legend. So guides is how you add a legend on for the fill. So we're going to add a guide for the fill coloring that we've just done here. So we've added the fill option. And this guide's fill equals guide legend. Call it name, override the guide legend, and give it the title, legend title. So you can choose, put your own text in. We'll see that rendered now in a minute. X label for the axes is species. Y label is petal length in centimeters. So we're just embellishing this and making this better. I've added a GG title, petal length in several species. I'm going to put of iris. Again, often we don't use GG titles. We don't put titles in our figures. We just have the figure and the legend underneath to explain it. But I'll do it there, so you can leave that blank if you want. We're going to add then, so this is, I suppose what I've done here as well, I've broken up my code a bit. So up here I've done kind of the plotting, if you like. This section here, first bit is me doing the actual plotting. This then here is me changing some of the text characteristics of the, actually specifying what text goes in where, what labels, etc. go on the plot. And then down here is me manipulating and changing the theme. So I'm changing here the theme. Instead of using the inbuilt theme, can't remember what it is actually, can't remember what it's called. We're going to use theme classic, which is the black and white. And we're going to set some different characteristics of the theme. So we're going to change the axis text, axis title, font sizes basically. So we're going to make those font sizes for all these 4 different things: the text for the axis label, the text for the ticks, the title for the labels, the text for the legend, and the title for the legend. We're going to make those bigger than default. I can't remember exactly what the default to, but these are slightly larger in every case. Right, so 12, 14, and 16. So the easiest thing to do is just have a look at that whole chunk and see what it renders to. So this is what we get. So we get our classic theme with the labels and text slightly enlarged on that. We get the 3 colors plotted like we wanted. Setosa is pink, yellow, and blue for the 3 different species, just as we expected from our command over here. That's our setting, our fill manual. If you were to change those, you would of course get 3 different colors. We've got data points jittered over on top of that, so you'll see that I haven't plotted the outliers with the actual box plot, and that's because this point here would be an outlier. and it would plot here as well, and it would make it look like we had, it would plot, the box plot geom would plot it here, and then the jitter one would plot it here. So then we'd end up with two counts of the same data point. So because I've added the data points on top, that's why I chose to suppress the outlier color by setting it to outlier color equals NA here when I built the geom for boxplot. The choice of points of shape equal 21 allowed me to have a black circle on the outside. So there's a fill option. There's also a color option. So if you wanted, you could set the color equals species as well. So here we've got fill equals species. There's also color equals species. That would let you change the color. You could even set color to be blue for all of them, or color to be red, or whatever you wanted, to have them all be the same color. I've let it be default, so I've let the color of the data points to be black by default, but the fill has been specified by species, so the code for species 1, 2, and 3, and then it's inherited the right color from that by the manual color palette that I specified: pink, yellow, and light blue. The upshot of all that is that in ggplot it's much easier in many ways than in base art to get the legend to work. The legend appears over here. I've just written legend title. That's not informative. You would of course want to you'd want to change that to, you'd want to, in this case it would be species, but we can put whatever you want there. In fact, in many ways, you know, this is an example actually of color that's redundant. You don't actually need the color here. We already know what the species are. We can see that here. The species are in the x-axis. This is Setosa, this is versicolor, and this is Virginica. There is nothing here that color adds any great amount of information on it. So typically we would color by something else. So if we had lots more box plots like this, you might color by male and female. You might color by native or invasive species categories. You might color by northern hemisphere species versus southern hemisphere species, whatever you want to do, but you typically have a color code that provides additional information over and above what is provided on the x-axis. So in this case it's complete overkill. There's no need for it, but it's a useful trick to pick up. So that's basically it. So the legend titles appeared here with the boxes telling us what color they are, and also the point type here in the middle for us as well. So there's more embellishments you can add here to the legend. You can change that. If you just look online, you'll find lots of options. But that's basically how we can make some pretty nice, I think, good looking box plots in ggplot2. So we'll pick this up with future ggplot examples down the line, I hope.